Oh hey, I didn't see you come in. It's just about to get started with our geometry lesson. Today we're continuing section 10.5, secants. Print out the PowerPoint, work the problems with me. Now let's get started.
It's Virtual Math with Mr. Ferrara. Hey, what's up everybody? Today we're going to be continuing with section 10.5 secants. We're going to be looking at segment lengths instead of angle measurements. Last lesson we looked at angle measurements. This lesson we're going to be looking at segment lengths. Now there are three possibilities when I draw in tangents, secants, or chords into a circle. Each of those three possibilities has their own unique formula. I recommend that you don't memorize formulas, that you remember concepts. Don't memorize the letters. Remember where those letters are located and what we're doing. In situation 1, we're looking at two chords drawn into a circle. When two chords are drawn into a circle, 4 segments are created. When I multiply the two pieces of one chord together, and I multiply the two pieces of the other chord together, they equal each other. So if you were using the letters in this picture, it would be A times B equals C times D. The two pieces of one chord multiplied together equal the two pieces of the other chord multiplied together. Situation 2 is when I have two secants drawn in. Reminder, secants are lines that go through the circle at exactly 2 points. So in situation 2, when I draw in two secants, there are sections outside the circle and there are sections inside the circle. So the formula in this picture would be W times W plus X equals Y times Y plus Z. The outside times the entire length of the line equals the outside times the entire length of the line. W and Y are the outside sections. W plus X is the entire section. Y plus Z is the entire section. The third possibility is tangent and secant. Reminder, a tangent is a line that grazes by the circle, touching it at only 1 point. A secant is a line that goes through the circle. So the tangent is labeled by T. The secant is labeled by Y and Z. So the formula is an adaptation of situation 2, and it's the tangent squared equals Y times Y plus Z in this picture. T squared equals the outside Y times the entire section Y plus Z. T squared equals Y times Y plus Z.
All right, so let's practice those 3 theorems in these problems 1 through 6. You may want to pause the video here, try the problem, see how you do. We'll compare answers right after you work them out. All right, hopefully you had a chance to look at those 6 problems, and let's take a look at them now together. In this first problem, I see a chord and a chord. So the first theorem we talked about was that the two pieces of each chord multiplied together will equal each other. So in this problem, I see that 3 and 7 are the pieces of one chord. 5 and X are the pieces of the other chord. So I know that 21 equals 5X. Divide both sides by 5. I find out that X equals 4.2. So straightforward problem, chord, chord. 4.2 is the missing piece of that chord. All right. Problem 2. We have 15 as a tangent, 8 and G as parts of a secant. So the third theorem says that tangent squared equals the outside times the entire length. So 15 squared is the tangent equals outside 8. Entire length is 8 plus G. Again, I don't like remembering formulas. Don't remember the W's, the X's, the Y's, the A's, the B's. It gets confusing. 15 squared equals the outside times the entire length. 15 squared is 225. Distribute to both of those, you get 64 plus 8G. I'm going to solve this equation by subtracting 64 to both sides. And I find out that 225 minus 64 is 161 equals 8G. Divide both sides by 8. I find out that G equals 20.125. That is the length of G. All right, problem 3. Looks like it's a secant-secant. That was theorem 2. 14 is the outside, 20 is the inside. 16 is the outside, X is the inside. So the second theorem, without the letters, don't worry about letters, says the outside times the entire length equals the outside times the entire length. 14 is the outside. The entire length is 14 plus 20. That equals the outside times the entire length. So again, theorems are hard to remember, especially with these letters. So I know that 20 plus 14 is 34. Then I need to distribute 16 to both of those. 256 plus 16x. 14 times 34 is 476, and that equals 256 plus 16x. I'm now in an equation that I could solve, so I subtract 256 from both sides. I get 220 when I subtract, and that equals 16x. Divide both sides by 16. I get an answer for x to be 13.75. Hopefully these aren't too bad. Problem 4 is a combination of all of the things from this chapter, from this section. So let's start with finding K first. So K looks like it's a secant-secant. Same type of problem that we just did. 9 is the outside. 12 and 9 are the entire length. 9 is the outside. 9 and 12 are the entire length. 8 is the outside. 8 and K is the entire length. Well, 9 plus 12 is 21. 21 times 9 is 189. That equals, distribute 8 times 8 to be 64. 8 times K is 8K. I'm at a two-step equation. Subtract 64 this way. We get 125 when I subtract 64, and that equals 8K. Divide both sides by 8. 125 divided by 8 is 15.625 for K. So there's K done. K is 16.25. Let's solve for R. R is this section right here. That means R is a tangent. R is a tangent, and I'm going to prefer to use this one right here since I don't have any variables. I know we found out what K is, but I like to not use my answers from previous problems in the next problems. So R, we don't know, that's R squared, equals outside times entire length. Entire length was 9 and 12, so I'm going to call that 21. Same as the last problem. 9 times 21 is 189. So R squared is 189. Pick up your calculator. We need to square root 189. And I find out that the square root of 189 is 13.75 for R. Now the last question is finding A, this angle right here. That's a review of last section. So whenever I have an angle outside of a circle, there are two arcs that are created. The larger arc minus the smaller arc divided by 2 gives me the angle. Large arc minus smaller arc divided by 2. 175 minus 60 divided by 2. 175 minus 60 is 115. 115 divided by 2 is 57.5. So this angle, A, is 57.5 degrees. All right, On to problem 5, where we have a little bit of algebra. So this is the baby algebra problem because it's pretty straightforward. It's secant-secant, so I'm looking for outside times entire length. Outside in this problem is x minus 5. Now they were nice in this problem because they clearly labeled how long the entire length is. That's 3x equals outside of the next secant is x minus 6 times the entire length, again, they told us very clearly, was 4x. Now I need to distribute the 3x into this one, and I need to distribute the 4x into this one. So 3x times x is 3x squared. 3x times negative 5 is negative 15x. 4x times x is 4x squared, and 4x times negative 6 is negative 24. So the reason this one isn't as bad is because those x squareds will combine together. I'm going to subtract 3x squared from both sides. I get negative 15x equals 1x squared minus 24. That should be a 24x. So now I'm going to add 24x to both sides, and I get x squared equals 9x. So the reason this problem is okay is because now the x's are going to divide each other. I'm going to divide both sides by x. Now the reason you can do that is because there's an x on the left and an x on the right, so they cancel each other out, and I'm left with the fact that x equals 9. So in that problem, x equals 9. Now the last problem, problem 6, has a little bit more algebra involved with it. This one we're going to have to factor. So this is a tangent and a secant. So I know that the tangent squared equals the outside times the entire length. So 36 equals x times x is x squared. X times 9 is 9x. There's nothing I can do except for move 36 to the other side, and I get 0 equals x squared plus 9x minus 36. That means I need to factor. So I draw in my x factor. Hopefully this is somewhere in your brains. Negative 36 goes up top. I need two numbers that multiply to be negative 36. 9 goes at the bottom. I need two numbers that add together to be 9. So two numbers that multiply to be negative 36, but add to be a positive 9 are positive 12 and negative 3. 12 times negative 3 is negative 36. 12 plus negative 3 is positive 9. So that tells me that x minus 12 equals 0, x plus 12 equals 0, and x minus 3 equals 0. Well, the nice news is one of those answers is going to cancel away. Subtract 12, you get x equals negative 12. X equals negative 12 can't happen because there's no way this distance is negative 12, so he's out. Add 3 to both sides, I found out that x equals 3 in this problem. If you wanted to do a quick check, 6 squared is 36. 3 times 3 plus 9. 3 plus 9 is 12. 12 times 3 is 36, which is what 6 squared is. So 3 is the only answer that will work here. If you have any questions on today's assignment, please feel free to Schoology message me, email me, call the Google helpline, or ask your questions during our next live conference. Till next time, bye.